What up, what up, y'all? Today what we're going to be doing is we are going to be talking about the water cycle, specifically standard 7.E.1.2, which states explain how the cycling of water in and out of the atmosphere and atmospheric conditions relate to the weather patterns on Earth. So let's get started, and the lesson title is 2.5, Where is Earth's Water? So let's break it down first, Earth's overall water. So the majority of Earth's water is located in the ocean. Around 97% of Earth's water is unusable by humans. We're not able to drink it because it is salt water. So we have roughly 2.5% of Earth's water is actually fresh water. Let's dig a little bit deeper though. The majority of fresh water is actually in glaciers, ice caps, or trapped underground, so we can't get to it. The other 1.2%, or I'm sorry, only 1.2% is actually on Earth's surface. So we have about 1.2% of the overall fresh water that is actually located at Earth's surface. Let's go even further into that surface water. So overall, humans have access to about 0.007% of the Earth's overall water supply. That is not a lot of an overall percentage to support over 7 billion people. So we do have to take care of our fresh water, and what water we do have available, we have to keep it clean and not pollute because we don't have access to a large majority of Earth's water. Roughly 3% of surface water is actually found in the troposphere as water vapor, and this is what we are really going to be focusing on with the water cycle. So that actually carries us into our next slide, which is the water cycle. What is the driving force of the water cycle? That would be the sun. That is an extremely important concept to understand. The sun is what makes the water cycle go. Its energy is the driver. In the water cycle, water's constantly changing between three forms: solid, liquid, and gas, or ice, water, and water vapor. The water vapor and parts in the atmosphere form clouds. So clouds are actually made up of tiny droplets of water, as well as also tiny ice crystals as well, depending on how cold it gets up there. Water can stay in certain parts of the atmosphere longer than others. A water droplet can spend up to 3,000 years in the ocean before evaporating into the atmosphere. What a long time to spend in the ocean. Whereas a water drop in the atmosphere only spends about 9 days before falling to the earth as a form of precipitation, whether that be snow or rain or sleet or hail. So it is different depending on where the water droplet is located at. Let's look at the water cycle's vocabulary terms. The first one is evaporation. The process of turning a liquid to a gas, that is evaporation. Happens all the time, but it happens the most over the oceans, simply because of surface area. The oceans cover around 70% of Earth's surface, so a lot of the evaporation occurs because a lot of Earth's surface is covered in water, and the majority of that is ocean water. So that is why evaporation occurs most over oceans. The second term I want to talk about is sublimation. Sublimation is the process of turning a solid into a gas. So in our terms, we're taking snow or ice and turning it directly into water vapor, with skipping the step of liquid in between. Sublimation typically occurs at higher altitudes where air pressure is less. Less air pressure allows for that transformation to occur more often. The other type of condition that you'll need for sublimation to occur is strong sunlight or energy. So you guys have probably seen sublimation before, just like this picture of dry ice. Dry ice sublimates. Dry ice is carbon dioxide in a solid form. And you see that kind of steam or smoke, that is the carbon dioxide turning into a gas from a solid. The next term that I want to talk about is transpiration. Transpiration is the release of water vapor from plant leaves. I like to think of it as like plants sweating, but that's just the way that my mind works. Transpiration rates depend on weather conditions like temperature, humidity, sunlight, intensity, and other factors as well. So it depends on the weather conditions on how much transpiration is occurring. So how it works is water is drawn up through the soil into the plant roots, where then it will go through the stem and to the leaves, and then it will actually evaporate into the atmosphere once it exits the leaf's pores. The next term is condensation, which is the process of water vapor turning into water droplets. If you've ever left an ice cold glass of water on a table or outside, you have dealt with condensation. This happens in the water cycle when warm water vapor rises and cools in the troposphere. Condensation forms two things. It forms clouds and it forms fog. Both of these are results of condensation. In order to form a cloud, you need two things. You need water vapor and you need particulates, which are tiny, tiny little pieces of solid. When a particulate and water vapor molecule meet, what ends up happening is the water vapor is able to condense onto that tiny particulate, and when there's enough water vapor and particulates together, that is what forms a cloud. And notice how this is all happening over here in this image over the ocean. The next one is something that we deal with quite often, precipitation, the good and the bad, right? Rainy days make it seem like bleh, but then when it snows, no school most of the time, and it's something fun to play in. So precipitation, in as simple terms as I can put it, is falling water to Earth's surface. It could fall as water droplets or ice crystals, but they fall when they get too heavy in the cloud. So when an ice crystal or a water droplet gets too heavy, it will fall to Earth's surface. And examples would be rain, snow, hail, and sleet. And if you look at this image, you have all four of those images in a little cartoon. And you know, if you have any questions about like what causes hail or what causes sleet, I'd be happy to answer those. The next two terms I'm going to talk about are infiltration and runoff. These two are very, very closely related to each other. So infiltration is when rain falls on land and is soaked up by the ground. So like a sponge. Water infiltrates the ground, and it is called then groundwater. Pretty complex name there, when it infiltrates the ground, it being called groundwater. The second term is runoff. And runoff is the water that flows over the land that is not absorbed by the ground. Eventually, runoff will end in a stream or a river and then travel to ponds, lakes, or oceans, is usually the final destination of runoff water. Continuing on with groundwater. Groundwater can be absorbed, can go through many different paths. It can be absorbed by plants. It can flow out of the ground and into bodies of water like oceans or lakes or ponds. It can also seep deeper into the earth. And if it gets to a certain depth, it can actually reach rock. And if the rock is porous, it's able to absorb that water in what is called an aquifer. An aquifer is simply a body of water that can contain groundwater. And if water reaches an aquifer, it can actually stay in an aquifer for thousands of years. So it can remain in the ground for quite a long time before it ever changes its place in the water cycle. So that was the presentation for the water cycle. I hope that you took quality notes in your online notebook. And the next step that you need to do is you need to read 2.5, the water cycle text. That is located in Canvas right after this lecture. And then the final thing you're going to do today is you are going to watch 2.5, the Great Aqua Adventure video in Canvas. And then one last requirement that you have to do for me is have a great rest of your day if I don't get to talk to you again. So thank you for listening. Thank you for making it this far. I hope you have a great rest of your day, and I will see you later.